Hi class, today we are reviewing our exponent rules. So what I want you to do to begin with is pause the video and see if you can write down these rules, what they are. You may need to refer back to our Algebra 1 star reference materials. They are posted in Google Classroom under Things to Know. So see if you can fill out what these rules are. So pause the video and try it. Okay, so here is what you should have gotten. We will talk about each of these in turn. The only one that was not on that star reference material is this zero exponent rule. That one is just one that you're going to have to remember. All right, so we're going to start up here. This is something we did a very long time ago, and we also reviewed it just a couple weeks ago, adding and subtracting monomials. So remember, this is just our combining like terms. And when we do this, the biggest thing to remember is that we do not change our variables and exponents. Those stay the same. That's why we're looking for a like term. All right, so let's look at this example over here. So in example number 1, we have 9x squared y minus 10x squared y. So those are like terms because we have the same names. They both have an x squared and a y with them. So then we're just going to take our numbers and we're going to do 9 minus 10. 9 minus 10 is a -1. And like we said over here, we are not going to change our variables and exponents. So we're just going to write those down. X squared y. Our next example over here says subtract 6w from 8w. That means if we write this out, we're actually going to do 8w minus 6w. So we need to look and see, are they like terms? Do they have the same letters and exponents? So they both just have a w, so that is okay. So now we're going to take our coefficients, the numbers, and we're going to subtract. 8 minus 6 is 2. And the w is just going to stay the same. All right, next we are going to look at our product rule. So with our product rules, when we have like bases that are being multiplied, we add our exponents. So in our example over here, we have a like base of h. So we're going to keep our base, and we add our exponents. So we're going to do 2 plus 6 in those exponents. So that would be h to the 8th power. So if you need more information on that, go back in our Google Classroom, look back at the previous lessons on these product rules. All right, on example 2 here, when we have our coefficients, we just multiply those. So we're just going to do -2 times 7. That's a -14. And then we look at our next. We have a's. We have a squared and a cubed. So we're going to do like we did above. We keep our base of a, and we add our exponents. So 2 plus 3 is 5. And then we also have these b's here. So we have a b and a b. Remember, when they don't have any exponents there, we have an exponent of 1. So we're going to keep our base b, and 1 plus 1 is 2. All right, next we have our power rule. So our power rule states that a base raised to a power raised to another power, so x to the a to the b power. We can do this simply by multiplying those exponents. So in this first example, x squared cubed, we're going to take the x, keep the x, and we're going to do 2 times 3. So then we have x to the 6th power. Our second example here, we're going to start combining some of these rules together. So we're going to use our power rules on the inside. Don't forget to take that power to our numbers also. So I first need to get rid of this power of a power. So I'm going to have -2. And we're going to multiply our exponents here. So 1 times 2. So all I'm taking is my exponent on my 2 and the exponent that is outside of that parentheses, and I'm multiplying them. And we get a 2. Next, we're going to take this m here. We have a 5 raised to the power of a 2. So we keep the base of m, and 5 times 2 is 10. And now we have an m cubed. Alright, so we're going to simplify -2 squared. -2 times -2 is a +4. And now we're going to use our product rule here. So m to the 10 times m to the 3rd. We're going to keep our base of m and add our exponent. So 10 plus 3 is 13. Okay, we have another rule, the quotient rule. So when we're dividing with the same bases, we subtract our exponents. All right, so here in example number 1, we can start by just taking our coefficients, that 27 and that 42, and reducing that down. So when we reduce this, we can reduce it to 9 over 14. So we have 9 over 14. And then we can take our x's. So I'm going to keep my base of x. I'm going to start with my top exponent number, so 5. And remember, there's not an exponent there, so we have a 1. So 5 minus 1. So that'll leave me with x over 4, or 9 over 14 times x to the 4th power. Sometimes you might see that x to the 4th power written up in the numerator with the 9. All right, in our next example, we have a power rule up here on top. It's normally easier if we simplify the numerator or the denominator first before we start using our product or quotient rules. So if we have y squared squared, remember our power rule states that we multiply our exponents. So y squared, so 2 times 2 is 4. Divided by y to the 4th. So now we're going to subtract our exponents. So 4 minus 4 is 0. So we have y to the 0 power. And here in a little bit, we're going to talk about how that is actually just 1. All right, our next rule is the negative exponent rule. This one is where students seem to have some of the most trouble. So the negative exponent tells us that our base is in the wrong spot of our fraction. So if it's in the top, we're going to move it to the bottom. You may also see where, I'm going to write it over here to the left side. If it's in the bottom, if our negative exponent is in the bottom, we move it to the top and make it positive exponent. So the trickiest thing here is that we only move the base with the negative exponent. So here my negative exponent is on the x. So my -5 is actually going to stay on top, and the x is going to move to the denominator, and that squared is going to become a +2. So doing this again, we have 4 divided by 8. We reduce those coefficients. That will reduce to 1/2. And if we use our quotient rule and we subtract, we have I'm actually going to erase this and use a different color. That way we can tell the difference in the problems. So I reduced the 4 over 8 to 1/2. If I subtract, I have my k in the numerator. 2 minus 5 is a -3. So I have 1 over 2 with k to the negative 3 in the numerator. So now, again, pay attention. We are only moving the term with the negative exponent. So that is that k. The 1 is going to stay up on top. So that means what we have now is 1 over 2 times k cubed. All right, and then the last rule we're going to talk about today is the zero exponent rule. So that states that anything raised to the 0 power is 1, but only the thing that is raised to the 0 power. So if I look here at my first example, we have 7 times x to the 0 power. So that means that I have 7 times x to the 0 power, which is 1. So 7 times 1 is 7. On our next example, we're going to have to use a couple of different rules here. So we need to start with the power rule up in the numerator. So w to the 4th power squared. We're going to multiply those. So we have w to the 8th over w to the 8th. And then we have to use our quotient rule to subtract and get rid of or make it one base. So 8 minus 8 is 0. And then anything to the 0 power is 1. Alright guys, so that is all we are going to go over today with our exponent rules. Again, if you need more help on any of these, look back at previous lessons. We go into more details about why these work the way they do back earlier. So you will just look for the laws of exponent practice problems, the notes back in our previous lessons. If you have any questions, please ask. On today's assignment, you are going to be correcting the mistakes. So you are given 6 problems that are worked out, but there is only one, there is a mistake made in each one. There is only one mistake. I want you to point out the first mistake that is made and then fix the rest of the problem. So it may have been one of the first things that was done. It may have been the last. So just be careful on that. All right, have a great day.